In our previous section, we have discussed about the OSPF domain ID. So today, in this module, we are going to discuss about the OSPF route type. So now let's have a look at this diagram. So in the diagram, we have on the left hand side, if you see this small diagram, we have CE1 and CE2 here, and we have the provider edge router PE1 and router PE2, right? So if we advertise some route from here, and remember that we are using, or we are working on the OSPF. So let's say we are having the area 0 here, and the same we are using area 0 here. Okay, so now let's say we advertise some route from here, let's say 8.8.8.8/32 into the OSPF. Now PE1 is going to advertise this particular subnet or prefix to PE2 because they are having the IBGP neighborship via this MPLS cloud. They will exchange the VP and V4 route, and PE2 will eventually get this route, right? 8.8.8.8/32. Now, first of all, it is going to check the domain ID, okay, if it is same or not. Domain ID we have already discussed in our previous section. So if the domain ID is same, right? Yes, or let's discuss first if the domain ID mismatch. So if the domain ID is not same, then PE2 is going to treat this particular subnet as an external subnet, okay, and it is going to advertise this particular route or prefix to CE2 as an E2 route or as an external route. So the domain ID is very crucial for us, that we discussed in our previous lecture. So now if the domain ID matches, then PE2 is going to check the route type. Okay, if it finds the route type is 1.0, 2.0, or 3.0. So 1.0 means the type 1 LSA, type 2 LSA, or type 3 LSA. So if the route type is these three values, then PE2 is going to advertise to CE2 the routes as an inter area routes. Okay, and if in the route type PE2 finds 5.0, 1.0, 7.0, or 7:1, then it is going to advertise the route as an external routes, either E1 or E2 routes, based upon the route type that it received. Okay, so now let's check it one by one and quickly match it with our scenario. So I'll go to R8, which is our CE1. So let's go to R8. So here we have the R8, show IP interface brief, show IP interface brief. So it is, we are on R6. Let's go to R8. So here we do have the loopback 0, show an interface loopback 0, show IP. Let's advertise this particular loopback into OSPF. Show IP OSPF 100. So we are running OSPF 100 here. So what we can do is let's check show run section router OSPF. So we are already advertising this particular loopback, right? 8.8.8. So now let's check at R4, show BGP VPN v4 unicast all 8.8.8/32, right? So now here you can check. So we are receiving this particular prefix 8.8.8, right? So we are receiving this information from the route reflector, you can see here, because 2.2.2 is the route reflector. We don't have the direct neighborship, we are receiving it via the route reflector, but the next hop value is 1.1.1 because the route reflector is not going to change the next hop. So we are receiving it from PE1, right? So 1.1 is the PE1 router. And look here, what we are receiving here is The extended community, this is the RT value, right? Which is the BGP RT value, the route target value, 300 colon 300. OSPF domain ID we have already discussed, right? So now look here, we also have the RT. So do not confuse this or do not mix it with the route target value. So this is the OSPF route type. So you can see here these four values 0.0.0.0, it means the area ID, because on the PE1 we are using what, area 0, right? If we use let's say some other area number, let's say I use area 51 at the PE1, then in the last octet you will find 51. Okay, so because we are having area 0 at PE1, that is why here you are seeing as 0.0.0.0. Now here you can see the it's 2 colon 0. So it is receiving this particular prefix 8.8.8 as an intra area route. Okay, as an intra area route, and this is the router id of the advertising router, which is PE1. Okay, originator, who is the originator is PE1. Cluster list, this is the route reflector IP. So now let's discuss about the route type. So route type, it is receiving 2 colon 0. So if we go to our diagram, so in our diagram you can see, if let's clean it. So if we receive uh, 2.0 or 2 colon 0 here, then PE2 is going to advertise the route as an OIA route, right? So let's verify it. Let's go to R6 and now check show IP route. Now you can see here R6 is receiving these routes as an inter area routes or OIA, and this is the same that we wrote here, right? So if the domain ID is matching and we are receiving type 1 or type 2 or type 3 LSA, then it is going to advertise as inter area routes. Okay. Okay, let's also check how we can advertise type 3. We can do one thing. Let's remove it. Router OSPF 100. Let's, as of now, let's remove this loopback advertisement. No, router OSPF 100, and let's remove it. Okay. What I will do is I will go to interface loopback 0. I will say IP OSPF 100 area. Let's try to put it in some other area, maybe let's say 80. Okay. Now let's go back to R4 and check the same output. Now you can see, because we changed the loopback from the advertisement of loopback 0 from area 0 to some other area. Now the devices are receiving, or the PE is receiving this route as an inter area route, right? If we check here at the PE or PE2, so you can see here now this value is changed. It's 3 colon 0, right? Earlier it was 2 colon 0, now it is 3 colon 0, because we are receiving this particular subnet now, or this particular prefix as an inter area prefix. But the rule is same for type 1, type 2 and type 3 LSA. It will be advertised as an inter area prefix. So you can verify this also. If you go to R6, still it will be receiving this as an inter area, right? It's still the same. Okay, now you need to also see this. So for type 1, type 2 and type 3, the route type value, if you go here at R4, the route type value, so this is the route type value, right? 3 colon 0. So in this value, if you look here, Just give me a moment. So if you look here, it's 3:0. So for the type 1, type 2, and type 3 values, or type 1, type 2, type 3 LSAs, this last bit after the semicolon, it will always be 0. Okay, because this bit, it is called the option bit. This is called the option bit, and this is used for the external routes only, because we have the external routes or external LSAs like E1, E2, N1, and N2. So this particular bit is used for those external routes. So if this value is 1, it means it's a E2 route. If it's 0, it means that it is even route. So it is a bit confusing. It's, you can consider it as opposite. So 1 doesn't mean that it is type 1 LSA. So 1 means it's a type 2 LSA. Now let's also verify it. If I go to R8 maybe, and let's remove this interface loopback 0. Let's remove it for the moment. What I will do is, uh, let's create one prefix list. Let's say name test, and I'll permit this particular loopback 8.8.8.8/32. Also, let's create one route map, name test, and I will match this prefix list here, match IP address prefix list test. Now what I will do is, I will go to router OSPF process at R8. I'm here right now, and I will do a redistribute connected using the route map. What is the name of the route map? It's test, right? Subnets. That's it. Now let's check at R4. It will take some time. Now you can see here the route type value is changed. Now the route type value is 5:1, right? 5 means it is the type 5 LSA, right? Because we have redistributed the loop back, so it is a type 5 LSA. And 1 means, as we discussed few minutes back, 1 doesn't mean type A, so it is a type 2 LSA, right? So it's a type 5 and external to LSA, right? So because when we redistributed it at R8, we did not mention any metric type as E1 or E2. So by default, it will be E2, right? So if we check at, if you look at our diagram, so if we are receiving a route type with a value of 5:1, now let's find out what we are receiving at R6. If I go to R6, now you can see here at, it is receiving as an OE2, right? So if we are saying the value of 5:1 here into the route type, so our PE2 is going to advertise it as an E2 route, right? Because 1 means it's a type 2 route. And as we discussed in our previous lecture as well into the OSPF domain ID, so PE2 is having only two options. So when it is going to advertise the particular routes, either it can advertise the routes as inter area or OIA, or as an external routes, right? Okay, so now let's try to change the metric from type 2 to type 1. So we'll go to R8, And what we will do is we'll go to the OSPF process, and we will set the metric type as 1. Now let's go back to R4 and see how it is receiving this route now. Now you can see it is changed. Earlier you can see it was receiving this particular subnet as a 5:1, but now it is changed to 5:0. 0 means it's a type 1 LSA. So now if you check at R6, so earlier it was receiving 8.8.8.8 as an OE2, but now we have changed the metric. Now let's see. Now you can see the change here. Now it is receiving this particular prefix as an OE1 because we have changed the metric type. Okay. So this is how these values work, the route type and all. Let's also try to do something so that we can also demonstrate this NSSA, how we can do that. Let's try like this. Let's go to R1, show run section router OSPF. Let's try to change something here so that we can advertise something related to NSSA. I'll go to the OSP process. My bad. I'll go to the NSSA, not NSSA. I'll go to the OSPF process. Let's remove this. So this is the interface which is going to the R8, and we are running OSPF here into area 0. I'm removing it for the moment. Let's try to run some another area here. Let's say the combination of R1 and R8. Let's say area 18, and I will say area 18 is NSSA. Okay, we'll do the same on R8 also. Show run section router OSPF. So we'll do a router OSPF 100. We'll remove it, and we will make the area ID as area 18, and what else we need to say is area 18 is NSSA. You can see the neighborship is up, and you need to make sure that you just configure the NSSA on both sides. Otherwise the area type will be different. One side it will be NSSA, it is not going to work. So just to make sure. So now the neighborship is up, and let's check now. Okay, let's change the advertisement also. Show IP OSPF interface brief. I'm at R8. Show IP OSPF neighbor. Where did we change? Show IP OSPF neighbor. Do show history. Let's do like this. Do show run section router OSPF. It is showing good. Why the neighborship is not up? Show IP interface brief. The interface is up. 18.1.1.1. So we are able to ping. Show IP OSPF interface brief. The interface which is going to R1 is F0 by 0. So on F0 by 0, still it is showing area 0. Okay, no problem. Let's remove it for the moment. Interface F0 by 0. Let's do like this. IP OSPF 100 area 18. show run section router OSPF. Now let's check here. Yeah, actually, I think earlier I was I have configured the command under the interface. That is why it was not picking up this one, because into OSPF, if you configure the OSPF using interface command and the network command, so the priority is for the interface command. So now you can check at R4 that we are receiving the prefix as in type 7, right, or NSSA 7 colon 0. So 7 mean it is NSSA, right, and 0 mean that it is type 2. So if we go to our diagram, so for types we are receiving 7 colon 0, right, 7 colon 0. Now let's check. 0 means E2 route, right? So let's verify this. So now you can see it's, sorry, my bad. 0 means it's a even route, right? 1 means it's a E2 route, and 0 means it's a even route, right? So if you go to R4, so we are receiving as an 0, right? 7 colon 0. 0 means it's a type 0 or 1. 1 means it's a type 2. I'm also getting confused because in my mind somewhere it is saying that type E1 means it's type 1. So 1 means it's type 2, 0 means it's type 1. Okay, so if we go here, so it's 0. 0 means it's a E1 route. So if you check here at R6, so it's a even route, right? Because we are redistributing using the metric. So if we go at R8 and check, let's go to R8, show run section router OSPF. As you can see here, we have set the metric type 1. That is why it is picking up the type 1 metric. Let's try to remove this and check. Let's remove it and change the metric type, or maybe we can leave it as it is, so that it will, by default it is going to pick up the type 2. Now let's go to R4. Now you can see it is changed from 0 to 1. So 1 mean it's type 2. Now here also it should changed from E1 to E2. Let's find out. So it's changed from E1 to E2, right? So this is how the route type works. So let me brief you quickly. So when we receive an information from the PE device, so first of all, the PE device is going to check the domain ID or the OSPF process ID. So if the process ID is same, or you can say if the process ID is different, so it is not going to check anything. So it is going to just redistribute the routes as an external routes, and only E2. It is not going to check the route type whether it is E1 or E2. It will just advertise the routes as an E2 route. Okay. If the domain ID is matching, then it is going to check the route type, and we do have the few options in the route type. So we have type 1 colon 0, 2 colon 0, 3 colon 0. So it is for the type 1 LSA, type 2 LSA, and type 3 LSA. For all these three type, in the after the colon there will be 0, because this is the option bit or the option field which is used for the external external LSAs. Okay, so for type 1, type 2, and type 3, this value will be 0. And for all these type 1, 2, and 3, the routes that the provider as device is going to advertise, that will be the OIA route. Okay, or as in type 3 LSA. And for type 5 and type 7, so it is going to advertise them as per the condition. If it receives as in type 1 LSA, it is going to advertise them as in type 1. If it receives as in type 2, it is going to advertise as in type 2. So this was all about the OSPF route type. So in our next section, we will discuss the concept of OSPF downbit. So if you like my videos, so I would request you to like and subscribe my channel. So see you in the next section.